Which is more than enough in today's political climate, David.
In general, we found very little close collaboration, or very little collaboration between the physics departments and the schools of education with regard to their physics teacher preparation efforts. By and large, the efforts were pretty segregated. And at best, the people in the physics department had some communication with the people in the education schools. But the way it usually works is that the students do their physics preparation in the physics departments. At a certain point, they get handed off. There's a handoff where they go up to the education school, and they are no longer seen or heard from by the people in the physics department, and they are then the responsibility of the education schools. And there's amazingly little feedback back and forth between the departments. Another striking and disappointing finding, not a surprising one, is that there is very little in any of these programs, with few exceptions, that focuses on the physics-specific pedagogical preparation for physics teachers. In other words, that basically have courses or programs or opportunities for students to learn about how to teach physics, not how to teach or how to teach science in general, but how to teach physics in particular. What are the best ways, what are some good instructional approaches for teaching mechanics or electricity and magnetism? What difficulties do students have when studying optics? What are some good assessment methods when you're trying to teach thermodynamics? Things like that. These type of very specific and very helpful pedagogical ideas are largely absent from the teacher preparation programs. And again, I want to make a point that this stands in very strong contrast to what is much more commonly done in other countries. Other countries that have physics teacher preparation programs, I don't want to say universally, but in many cases, do have and have for a long time, have those focused courses, or usually sequences of courses that focus on physics-specific pedagogy. Just as there is very little contact between the physics departments and the schools of education, there is equally little contact between the institutions, and here I include both the physics department and even the schools of education, with their recent graduates. So what it means is that nobody really knows what happens to their graduates. But the physics department's lost track of them, several years before 1 or 2 years before they even graduate. But even the schools of education tend to do very little follow-up and don't know where their graduates have gone, how successful they've been, or don't get much feedback. And certainly, the key is that neither the physics department nor the schools of education put themselves in a position or are in a position to provide ongoing support for their recent graduates, support of any type. There's some informal support, of course, where somebody goes out teaching and they have questions about some instructional technique or some lab activity, and they make informal contact with their previous advisor in the physics department. That does go on, but there's very little or almost no formal efforts, again, with very few exceptions. And it's a particularly troublesome point because it is well known that new teachers face the biggest obstacles in their first year and their second year. That's where they need the most support. And physics teachers, in contrast to teachers of many other subjects, have very little support at their new institution because they are often the only physics teacher there, or perhaps there's one other physics teacher there. So you have really no community for support.
70% of physics teachers are the only physics teacher in the building.
So they do tend to feel much more isolated than teachers of other subjects.
Do you feel that this affects the ability to get why people are leaving?
So what's that?
Do you feel that this is an important factor in why people are leaving?
Yeah, we do feel that. Again, we don't have data to support that strongly, but there's a lot of anecdotal data to suggest that it is those feelings of isolation and that and things that are related to that make it harder for teachers to withstand the real pressures and rigors of those first 1, 2, 3 years of teaching, and do accentuate the movement away. Yeah. Again, it's not something we investigated rigorously. We've alluded to the fact that a large number of the people who become physics teachers do not have substantial background in physics. In other words, of the 1,200 each year who become physics teachers, only about 400 actually have degrees in physics. Many of the others are converted from their background of teaching some other subject, for instance, biology. They have a background in biology, they teach biology, but they are forced through various circumstances to teach physics courses at their high school. Even though that is the case, and they, in most cases, both objectively and subjectively do not have the kind of background that is either optimum or desirable for doing that job, and there is very little support provided for them, there's very little support available for them, and certainly, and this is the key point here, there are very few professional development programs available at universities that might offer support to these teachers who are switching over from converting from being, say, a biology teacher to being either a biology plus a physics teacher, or converting to just, well, I would say in most cases they are probably keeping their foot in their previous field. They're still teaching one of the course they used to teach, but they are also now teaching physics as an add-on to their job. But there's, again, very little institutional support to help train, to help them, bring them up to speed on their physics. So this is the summary. I don't know if there's anything. This is just a summary of those points. It's a pretty, as it says, it's a pretty grim picture. And so the feeling you get is that the overwhelming sense in most students who are becoming physics teachers is they're sort of doing it on their own with, at best, one faculty advisor. They're very isolated within their department, they're very isolated within their institution, and once they get out to teaching, they're very isolated on their job. And so, I think, is that the end of that section?
But wait, there's more!
We also found, this is finding number 8, which was the sort of the silver lining, and that is there exist thriving programs out there that can serve as models. And so those programs incorporated several, although none incorporated all of the following points. So a program champion, as we said, was the hallmark of all the thriving programs that we found. Active collaboration between physics and education departments. This is something that I'm not sure how much people who are at the specific institution actually appreciate the affordances of the institution. CU Boulder is really an exception to this rule. And there are very few institutions in the United States where there is active collaboration with the physics and education department. A sequence of courses that concentrate on physics-specific learning and teaching strategies. And I wanted to actually mention a point that is often missed in these kinds of discussions, and that is that biology, physics, chemistry, earth science do not just differ in the subject matter. So it's not that biologists just look at living things and the physicists look at dead things, right? But there is a particular disciplinary perspective that actually funds the approach. And so that is something that we feel is an important part of learning what it means to do, to become a disciplinary expert. It is not just about knowing Newton's law or knowing about evolution or knowing about tectonic plates and that kind of thing. But it's about what kind of disciplinary perspective somebody brings. Early teaching experience is led by the physics department. Individualized advising of teacher candidates by faculty knowledgeable in physics education. There is mentoring by expert physics teachers at these thriving programs, and there is also a rich intellectual community for graduates. So on the basis of the findings and on the basis of our reading of the literature, physics education research literature, and teacher education and development literature, we have come up with the following 13 recommendations. So, before I tell you the recommendations, I want to give you 2 caveats. First is that this is a call to action for physics departments. And here's a little inside joke, and that is that physicists think a lot about action, but they think about least action. And so, because least action is a mathematical description of how things, of mechanics. And also here's another example of least action. Find x, here it is. So
least action is what happens without human intervention.
Without human intervention, exactly. So the first caveat is that there has to be a strong action that is taken by physics departments. The second caveat is that no, your institution is not doing all of these things. No institution is doing all of these things in the United States. So recommendation number, or the recommendations are grouped in 3 categories. The general category of commitment. Physics and education departments, university administrators, funding agencies, professional societies, everyone has a very important role to play in the preparation of physics teachers. Quality, and we decided, how does one define high quality physics teacher? That was something that we agonized over. And we decided that the focus had to be on student learning in the pre-college classroom. What are the factors that contribute to improved learning in the pre-college classroom? And finally, recommendations to increase capacity of the system. And we propose that they are the only way that you can solve these problems is through multi-partner collaborations that will pool resources and expertise in order to be able to do these kind of things. So commitment. Schools of education and physics departments have to recognize that they share responsibility. There is a long list of things that is associated with what that means for physics departments. The second one is that institutions for which the preparation of STEM teachers is a major part of their mission need to not go at this by themselves, but to join national efforts. And in these national fora, there is an opportunity for actual dissemination of successful strategies. And PhysTech is one very important national initiative that is specific to physics teacher preparation. There are other initiatives, for instance, SMITI, that CU Boulder is associated with, the Science Math Teacher Imperative of the American Association of Public Land-grant Universities. Okay. Disciplinary societies need to keep pushing the issue and provide, disseminate models for the collaboration between disciplinary faculty and sciences and in the schools of education in order to improve teacher education. The National Science Foundation and the U.S. Department of Education have long held incoherence as an important virtue. And I think that individuals in the agencies recognize. As a matter of fact, program officers at NSF that we have shared these recommendations have actually said, we welcome this voice coming from the outside, telling us that we have to develop a coherent vision that does not isolate pre-service from in-service. Quality. PER-informed teaching should be there at all levels.